Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's SecurityBoulevard.com webinar, brought to you by TechStrong and Cyral. My name is Cody J. Brown. I'm the host of TechStrong Learning. We have an exciting presentation ahead, but before we begin, I have just a few housekeeping notes. First, today's session is being recorded, so if you miss any of today's session or you just like to share it with a friend, the recording will be sent to you via email shortly after the webinar concludes. If you have any questions for Rob during today's seminar, we want you to use that Q&A tab on the right side of the screen. Any questions that you have, go ahead and put them in there and we'll try to address them as soon as we can. And if not, we'll get to them at the end of the program. If you have any other comments or you just want to add to the conversation that's going in the chat tab, go ahead and find that on the right side of your screen. My last note, at the conclusion of our webinar today, we will have a drawing for 4 $25 Amazon gift cards. So onto our topic at hand. We will be discussing leaving shared database accounts behind, securing Snowflake and MongoDB. And I'm joined today by Rob Richardson, developer advocate at Cyral Inc. Rob, it's my pleasure to turn the floor over to you. Thank you so much for being here with us today.
Yeah, thanks, Cody. I'm so excited to be able to show you some of the dangers of shared database accounts and how we can solve that. Thanks to Cyral for sponsoring today. Thanks for joining us here at Security Boulevard. Here's the part where I tell you I am definitely going to post the slides to my site tonight. I've been chasing similar speakers, which is why you can go to robrich.org, and these slides are online right now. Let's head there. When we hit robrich.org, we'll click on presentations here at the top. And here's leaving shared database accounts behind, securing Snowflake and MongoDB. The slides are online right now. While we're here at robrich.org, let's click on About Me and we'll see some of the things that I've done recently. I'm a Cyral developer advocate. If you're struggling with your data mesh, I would love to learn from you. I'm also a Microsoft MVP, a Docker captain, and a friend of Redgate. AZ GiveCamp is really fun. AZ GiveCamp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver the completed software to the charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ GiveCamp. Or if you'd like a GiveCamp closer to where you are, hit me up on email or Twitter and let's get a GiveCamp in your neighborhood too. Some of the other things that I've done, I replied to a .NET Rocks podcast episode. They read my comment on the air and they sent me a mug. Woo! So there's my claim to fame, my coveted .NET Rocks mug. So I'm grateful for Cyral for sponsoring today. We're going to take a look at how we can dig into shared database accounts and really focus on data access governance. So let's do that. Data access governance. Data access governance is about who can access what data, with what constraints, under what circumstances. Now, breaking that down a little bit, who, what, where, when, how. The only one we're missing here is why. And our logs can't really tell us why, but that's probably what we're reaching for. But while we step away from why, we really want to validate that users are using least privilege. We want to give them enough permissions to accomplish the tasks they need to do, but not so much that we risk losing data. By comparison, users are probably focused on data store authentication. The analogy here I like is a key. If I'm in front of a door, I just need a key to open the door. I just want to get inside. I don't care which key gets me through the door. I need a key. Hey, do you have a key to this door? Yeah, users are focused on getting into the database, not so much on using the correct key to accomplish data access governance. When we compare these two, we can take a look at data access governance that is really trying to validate that users are who they say they are, that they're using data appropriately. In comparison, when we're just looking at authentication, we just want to open the door. The difference between these really boils down to who accessed your data. Now, who accessed your data is a wonderfully easy question to ask, but, well, it's really difficult to answer. When we're looking at user identity details, it's kind of hard. And it's hard, I would propose, because the majority of the time, we don't know. We know that that key was used to open the door, but we don't know who was holding the key at the time. And that's where data access governance gets really difficult. We're using shared accounts. We're using shared accounts because it was easier to administer, but once we start using shared accounts, we lose that user identity detail. When we look at user authentication, we probably break it down into three main strategies: user-specific, group or team accounts, maybe role or function accounts, and service accounts. Let's dig into each one and see if we have any concerns. As we're at this point, though, any questions so far about user accounts, the importance of tracking user logins, or data access governance concerns? Great, let's dig in. User authentication strategies. We probably are using one of these three. Let's take a look at each one, the pros and cons with each approach, and the things that we might choose to give up as we focus on data access governance. First up, user-specific accounts. With user-specific accounts, we have one account per user in each data store. Now this is great. We can tune the permissions specific for each user. We can ensure that they have enough permissions to accomplish their task, but still have least privilege enough that we're not giving excessive permissions that might lead to data loss. Now it does scale badly. In this example, we have 3 users trying to use 5 different data stores. So we need 15 accounts across all these data stores to ensure that these 3 users are able to access each of the 5 data stores. It's really an exponential problem. Let's add a 4th user, and now we need to add 5 new accounts. Let's add a 6th data store, and we're up to 24 accounts. Now that's just 4 users and 6 data stores. What if we have 100 users in our company and 100 data stores, which is not unreasonable given a microservices-based approach? If we have 100 users and 100 data stores, assuming every user has access to every store, we now have 10,000 logins across our data stores. That's a lot. And 100 users isn't that many. Maybe what if we had 1,000 users or 10,000 users? 1,000 data stores or 10,000 data stores across all of our microservices. We can see how this exponential problem can really get out of hand really quickly. On the upside, user-specific accounts are great for being able to give least privilege. We can tune our permissions to each specific user. And they're great because if an account gets compromised, we can shut off that one account without really impacting other users. The blast radius is pretty small. Now that's great, but we saw how difficult it was to scale. Just setting up our system with 4 users and 6 data stores, we already had 24 accounts. If we had 100 users and 100 data stores, we have 10,000 accounts. Now that's just getting started. How users enter our organization and leave our organization, or maybe move different teams, we'll need to keep up with all of those changes. Basically, we are copying our identity store users and groups into each database's authentication system. That's a lot of redundancy. Probably, we need a dedicated team to try and keep up with this workload. That's a lot of management toil just to try and duplicate what we already have in our identity provider's authentication directory. On the upside, user-specific accounts are great where we can tune permissions in a really elegant way. On the downside, we have to spend a lot of effort trying to keep up with this. This usually requires a dedicated team, and that team probably has a pretty large backlog. If a user leaves the organization, how long until we're able to catch up with that user and shut off their access? That's a lot. Next up, shared team accounts. Now, shared team accounts are interesting because we've started to scale away from one account per user and focus instead on one account per team or group or function. We create one account per role or function, maybe one account per team. And so our 100 users probably break into a dozen or half a dozen teams. Let's say we've got 10. Okay, so now we have 10 teams across our 100 databases. We only have 1,000 accounts to manage. That's a lot easier. Now, that's cool, but these team accounts are shared. So Now we can get these accounts set up. Maybe they're more durable, they last longer, but the nature of them being shared is that, well, people tend to share them. Hey, can you give me the account details for this database? Yeah, sure, let me Slack that to you. Did we post our credentials in Slack or Teams or our communication strategy? Was the other person on our team? Hey, I only need to open the door. I don't care which key I'm holding, and it's a shared account anyway. Why don't you just share it with me? Now, what about the people who leave the team? When's the last time that you rotated the credentials? Now, back in the day, we could draw a circle around our VPN. And so we could say, hey, all of our data stores are in the VPN. The moment that you leave the company, we'll shut off your access to the VPN, and you'll no longer be able to get at this data. But in today's cloud-native world, where our databases live in the cloud, and our applications and BI tools live in the cloud, and users connect to them with a browser, none of those things pass through our VPN. How do we secure the data that doesn't go through our network? Well, that's where Zero Trust is really helpful, but in this case, we're using shared accounts. We're not using Zero Trust. And once we shut off a particular account, we have a much larger blast radius. It becomes much more urgent to get that account back online because we've disabled an entire team or an entire function when that account gets compromised. Yeah, it's really difficult for us to keep these accounts from getting shared excessively, and we've lost the user context, the user identity. We know somebody was holding this particular key when they opened the door, but we don't know who was holding the key. Were they on the team that was assigned this role? I hope so, but we don't know. On the upside, we have much less management toil, much fewer accounts to copy from our identity store into our database's authentication system. On the downside, it's difficult to prevent these accounts from getting shared excessively. And when's the last time you rotated the keys associated with this account? Have you ever? It's really difficult to avoid excessive sharing with shared accounts. After all, they are shared accounts. And once we lock it out, we've locked out quite a bit more activity. Next up, let's take a look at service accounts. Now, service accounts are great for non-human activities. When we have a computer doing something perhaps on a cron, on a scheduled task, that's the perfect use case for service accounts. After all, we can't exactly have the system, we can't exactly tell a computer, hey, can you reset your password every 30 days? That's just not something our automation is built for. Probably if the service answered, you need to reset your password, then we'd say, you know, the automation is broken until a human jumps in. Service accounts are great for these non-human interactions. On the upside, it is the perfect solution for automation. When there isn't a human involved that can click the login button or the change password button, then a service account gives us great reach. On the downside, the assumption is that these service accounts will live for a really long time, maybe infinitely. Your AWS S3 account token and security key, when have you rotated those recently? And it's also really easy to misuse these by people who just need the door open. And in particular, we have completely lost any kind of user context here. The user identity is just gone. We can presume that maybe we have external logs that identify which user was using the application that kicked off this task, but we're really no longer tracking users anymore. Here's an example of service account abuse. I don't have access to the application or the data store. I just need to get into it. So I'm going to pop open the application's configuration file. I'm going to go grab the token and secret. I'm going to use that to log into the data store, and I'm going to get my job done. Great. Check off that Jira task. But I was in and out without a trace. From the database's logs perspective, all we know is the app did something. We can assume that it was the app, but in this case, it wasn't. But surely users are logged into the app. Can't we just use the app's application logs? Well, we could, But that makes an assumption. It makes the assumption that all traffic coming from this application to the database went through the application. Now, we talked about how a user just popped open the configuration file and did bad things, but here's some other legitimate examples of people who might dig into the database without going through the application. Here's an SRE who just needs to help a customer fix some data. So they log into the data store, they go adjust the customer's data, and now the customer is unblocked and back online. Or maybe we have a DBA who's rebuilding a database, index, or who's crafting a stored procedure. They'll probably use their SQL query tool, not the application, to accomplish this task. How about a bulk data extract or an import? Now, we're probably not using the application because an import came from whatever format their old system gave them. So we probably need to take a couple of rounds through to make sure that we've passed validation and that we've get our data into place. Or a migration tool. As we're deploying new versions of our application, we might have a tool that adjusts the data store schema to match the application's new needs. Now, that's not going to go through the application. It's just going to log into the data store and run SQL queries. Or I just needed to do this once. I don't care about which key I used to open the door. Let me just pop open that configuration file and steal the details. And in each of these cases, we have access to our data store that did not flow through our application. If we're assuming that our application's access logs give us our database's access logs, then in each of these cases, we are mistaken. The application access does not equal data access. What are the other places where you have legitimate access to your database that doesn't flow through your application? Service accounts. Service accounts are great for non-human type of interactions, but we see how easy it is to misuse them. We must assume that all access is through the application if we're going to have any sense of logs associated with this, but then we must lean on that third-party system to be able to get access logs for our data. And if we have sufficient logs there, maybe that's okay, but all we have from a database's log perspective is that the service account did something. We have completely lost all identity authentication, all identity information. So those are the three strategies: user-specific accounts, group or team accounts, and service accounts. Each of them have their benefits and best use cases, but each of them come with some really severe downsides. With user-specific accounts, we probably need a dedicated team to keep up with our organization's org changes, copying that data from our identity store into our database authentication systems. With a group or team system, we probably need to combat excessive sharing. After all, it is a shared account. Why wouldn't they just share it with others too? And with service accounts, we must assume an external system's logs are sufficient, and we've seen lots of examples where that isn't the case. We've lost all user identity information with the service account because all we know is the service account was used. Any questions or concerns about these user authentication strategies? So yeah, these are the three, and it kind of leads us to this scenario. So how do I do data access governance if the only strategies for getting user identity into place have a mountain of issues? Either I need an increasingly large team to handle this, or I've made assumptions about user context. I don't know who's holding the key. How do we do this? Let's take a look towards application access and see if we can get clues for how they're able to solve it and start to leverage that inside of our data access governance concerns. Towards application access, we probably have a system like this. We launch a web app, we click the login button, we're redirected off to our identity store. Maybe that's Okta or Azure Active Directory. We log in, we come back to our application, and we get stuff done. Now that's really elegant. That's a really seamless and uh, beautiful experience. In this case, the identity provider, the application or service provider, and the user all work together to create this really elegant experience. In this scenario, the identity provider is the only one that has authentication credentials. We don't need authentication credentials in each of our applications. They only get stored in one place. As we adjust user permissions in the identity provider, they take effect in each application that leverages this. As the user approaches the identity provider to log in, they get an authentication token, maybe a JWT, a JOT. That JOT gets passed into the application, and the applications then can make authorization decisions based on that verified user's identity. The application can log the user's identity and the user's group, but they didn't need to authenticate to the application. They authenticated to the identity provider. From the user perspective, they just click login, and if they were already logged into the identity provider, to their SSO provider, then maybe they go straight into the application without having to enter their password again. It's a great experience where the identity provider, the application, and the user work together to make this happen. All our credential data is stored in one place, and the applications are able to make authentication decisions based on that JOT token. Why can't we do SSO with data stores in the same way that we did SSO with applications? Well, part of this experience with SAML and OIDC is that redirect process. With a web app or with a cloud platform, we can redirect off to that identity provider to get a login. In databases, imagine your database client replied with, "Hey, can you log into this URL?" How does our application handle that? We really can't. We don't have a SAML path for on-prem data or cloud-based data. We just have these proprietary connections on proprietary ports, connecting using interesting ways. Let's take a step back. What do we want in this process? Well, let's return to our data access governance metaphor. With data access governance, our goal is who can access what data, with what constraints, under what circumstances. Let's see how we can leverage applications metaphors to be able to get to that spot. What's our ideal scenario? We want user-specific activity logs. We want SSO access to that data to avoid the toil of syncing our identity provider into our database's authentication systems. We want to be able to easily shut off a compromised account with a small blast radius that doesn't impact other teams or other users. And we want to automatically block unusual activity. Here's our ideal log. We want to grab our SSO username and group, the SQL query, the result count, client connection details, maybe their client IP, and the date and time of the request. Now, as we look at this ideal log for databases, this is pretty much exactly what we have with applications. We have the user's identity, their SSO username and group. We have the request URL. We have the response status code, maybe the byte served. We have the client's IP and the date and time. This is exactly what we have with applications, and this all flows into our SIM, where we can make business decisions based on that activity. Let's see if we can get there with our data. Let's add Cyral. Cyral simplifies security and governance for databases and data lakes. The cloud-native service is built on stateless interception technology that enables consistent visibility, access control, and authorization. Cyral enables DevOps and security teams to automate their data security management workflows and to prevent data theft. The cool part about adding Cyral is we get that SSO experience into our data. We get federated access control, consistent visibility, unified policies, and real-time attack response. We're going to use Okta in our demos today, but we can also authenticate with Google Workspace or Azure Active Directory or others. We're going to dig into Snowflake and MongoDB today, but we could connect from Postgres, Oracle, SQL Server, other relational and non-relational stores including some unusual stores like S3. Now, isn't it cool to be able to authenticate to S3 with SSO coming from Okta? And then we can get universal policies that apply to all of our data stores. If I have access to this data in this data store, when ETL moves it to that data store, I should still have that same access. Or if I don't have access in that data store, I shouldn't have access in this store either. And all of this data flows into our SIM. In this case, we're going to look at Elk, but we can also send this to Datadog or to Splunk or to that provider that you're looking for. We also have integrations that allow you to do just-in-time access with Slack or with Git. Let's take a look at a network diagram and see how Cyral is able to facilitate SSO in this way. Let's first start with our system without Cyral. Now, in this case, we have a user. Maybe this is a frontline worker that needs to be able to access our data and make transactional adjustments. Probably they'll log in with SSO. Maybe they log in with a username and password to a web app. In time, that web app may call a backend API, and that backend API is going to save some data. In this case, we'll use Mongo. In time, we may want to take that transactional data and put it in an analytical data store. So we have this Spark ETL process that pulls the data from Mongo and pushes it into Snowflake. Now, a BI user may approach a BI tool. In this case, we'll look at Tableau, and they pull that data from Snowflake. As we start to look at this diagram, let's take a look at the various accounts that we have and the authentication strategies that we're using here. Well, Spark is a great example where we have no human involved, so we need a service account here. There's a service account that logs into Mongo and a service account that logs into Snowflake. There's no human, so that's the correct solution here. But as the user logs into our web app, did they need credentials specific to this web app? Ideally, they're using SSO, perhaps from Okta, to be able to get in there. And then that JOT will get passed from the web app into the API. But I bet the API doesn't take that user identity to validate the connection into the data store. It's maybe just going to use a service account. Now, in this case, we have a human. And so do we really need a service account? Maybe we use service accounts for optimization of our connections, for connection pooling, but we can still pass that user identity into our data store connection. Looking at the other side, our user connected to Tableau. Now, based on the number of licenses that we had for Tableau and Snowflake, we might have used a shared account. After all, that reduces our license cost, that reduces our cloud expenses. So maybe the user authenticated with a shared account into Tableau and a similar shared account into Snowflake. So how are we going to use data access governance in this scenario? We don't necessarily know that the service account is used exclusively for Spark. We don't have any user identity information coming from our API into our Mongo database or coming from Tableau into Snowflake. We need to make some assumptions and lean on the APIs and the Tableau logs, and this doesn't even account for access from other systems. Let's add Cyral. Now, we do have more moving pieces in this diagram, but a lot of these moving pieces are already existing in our infrastructure. We've called out Okta here. We're going to authenticate to Okta in all the places, and we're going to push our logs to our SIM. In this case, we'll use Elk. We also added the Cyral control plane that allows us to make decisions about how we'll authenticate to various data stores. And we have a Cyral sidecar. This sidecar, like a sidecar through Istio or Linkerd, allows us to proxy connections into our data store. So instead of authenticating directly to the database, they'll authenticate with this Cyral sidecar that can go check in with Okta to validate this connection works as expected. And the Cyral sidecar can pass the logs into our SIM of choice. So in this case, the user is definitely going to authenticate with Okta. They'll get that JOT, pass that into the API, and the API can pass that to the Cyral sidecar. They can use that to validate the connection and pass that data on to our SIM. Once the Cyral sidecar receives that authentication details, it can proxy that connection off to the data store, and the REST API doesn't know anything about they're connecting to a sidecar. They just get a response that matches their Mongo connection, and everything works great. In a similar way, we have our Spark ETL job. Now, it logs into Mongo and Snowflake, but it's using the service account to log into the Cyral sidecar instead. At this point, Cyral can validate that this service account is coming from only the Spark process. Perhaps we're validating the application name or the client IP address or other RBAC details to validate that this service account is not used outside of the context of this one approved activity. Spark is able to get at that data from Mongo and push that into Snowflake, and we get the details of that pushed into our SIM as well. As users approach Tableau, they can validate from Tableau into the Cyral sidecar, and that activity log will end up in our SIM as well. It's great that we can add Cyral in this way to be able to get user identity context for both Mongo and Snowflake, where previously we didn't know what users were connecting to our data store. That allows us to make some great data access governance decisions based on the data that we have flowing into our SIM. Any questions here on our architecture before we dig into a demo? Great. Let's show our demo right here. Now I've got Okta set up. Here's my Okta connection, and I have various groups in here. I'm going to be using DevOps and SRE in this demo, but we also have an automation group here. Now this automation group has the service account for Spark, and we can see that service account right here. Back in our groups, we can see that I'm a member of the DevOps group, so I'm going to log in as myself. Here's Rob. And as we look at our applications here in Okta, we can see that we have an application for Tableau, but we also have this Okta FinTech that we'll use in most of the demos today. Now, Okta FinTech has been given access to the DevOps group, DevOps, but it also has automation in there as well. Next, let's flip over to the Cyral control plane. Now, here in the Cyral control plane, we've set up various data repositories. Now, we can hook into lots of different databases. Here's SQL Server, here's Postgres, S3. In this case, we're going to dig into both Mongo and Snowflake. So here in Mongo, we've set up our connection off to Mongo Atlas. And so here's our Mongo Atlas cluster. And then we proxy that content through the sidecar. Now I'm going to authenticate with this SSO group coming from Okta, and that last mile is going to be using this account. Now we only need one or maybe a handful of accounts in our database, and our sidecar can take care of all of the other validation, grabbing all of the users and aggregating those into these specific accounts. Similarly, when we have our setup with Snowflake, Snowflake passes it off to the final Snowflake machine, but the Cyral sidecar will be able to validate these SSO groups and pass it in the last mile using this account hardwired into Snowflake. Now, similarly, here in our application, we have various data maps. Now, I'm specifically identifying these fields inside of our database and giving these generic labels to them. Flipping over to Mongo, we can see that we've got our collections mapped in a similar way. So if you try to access the location.address in the customer's collection, then I'll give it a tag of address. Account balance in various places, I'll call that balance. And phone, I'll call that phone. And so these labels then can apply across data stores. Let's take a look at the policy. Now I have two policies, one for sensitive information and one for read-only information. Taking a look at this policy, I can see that for all of these types of data, I will have these rules. So I'm going to say that DevOps and SRE have access to read only 10 rows at a time, and they can update only one row at a time. and delete only one row at a time as well. Now, that's a good default for helping avoid data exfiltration, but I can also tune this to avoid trickle exfiltration as well. If you're not in the DevOps or SRE group, then you don't have access to this data store. Similarly, let's take a look at our read-only policy, and I can see in the read-only policy, limits about the number of rows probably don't apply because I'm doing bulk analysis. But for each of these read-only fields, the DevOps and the SRE groups are able to read an unlimited number of rows. And the automation team, the automation accounts, are able to read any number of rows and update and delete any number of rows as well. So as Spark goes through and grabs all the data from Mongo, it's able to update this data even though this is a read-only database for DevOps and SRE. That's great. So now that we've got these details in place, both in Mongo and in Snowflake, configured through these sidecars, let's make a connection to our data store. Now, unlike where we have this application hitting this API, we saw that there were other tools here that might hit the data access, the database as well. So we're going to use a data access tool. In this case, we'll use Mongo Compass. Now, to be able to get into Mongo Compass, we'll come here into the Cyral console. We will click on our data access portal, and we'll be able to get specific instructions for each of the data stores that we have access to. So let's dig into Mongo Atlas. If I'm using a tool and I just need to copy in all the details, I can copy each of these details into place, and that will get me access to the store. Now, this password is a very short-lived token that allows me to authenticate into that data store for just a few minutes. Cyral is going to rotate that secret so that I can validate that I still have permission into Okta. They've also assembled this into one connection here. So let's copy this content here. And I'm not going to log in with the Mongo shell, so I'll pull that off. And let's adjust this slightly because I'm going to log into a different database here, TPCH. And now that we have these details, let's use that to log into Mongo Compass. Now we'll notice that I'm getting access to Mongo Atlas data, but I'm doing so through my sidecar. Now that I'm in my database, we can take a look at the collections that I have in my TPCH database, and we can see the documents and the quantity of each. Let's dig in and take a look at a particular customer. So I'm going to start out. I want to take a look at all customers. And right away, we can see that we get a database error in the normal way that we might get any other database connection error. In this case, the error message says, requested more data than allowed by the policies. Now recall here in our policy, we very specifically identified that we could only read 10 rows at a time. Now that's perfect. We've hit exactly that limit, and we've been blocked from accessing more data than is necessary. Okay, let's come in here and let's only query 10 rows at a time. And now I can see all of the data that I need to. Now, we're only securing the fields that we really care about. So if I were to select different amounts of fields, let's look for the ID, and let's look for the name, and let's look for the market segment, and let's look for location.nation. We secured the account balance and the phone and the address, but not these other things. So now I can remove my limit, and now I get access to as much data as I need. The data that we're really worried about is secured based on the rules that we've created, and we have the ability to get at more information for the fields that we're less worried about. So there's our customers. Let's also take a look at orders. We can see that we have a similar limit on orders, so let's only select 10. And like any document database, we have our nested line items, and we can dig into the particular details about those orders. So of course, our Spark job needs to be able to select this data out of our document database and push it as relational data into our Snowflake database. So let's now flip over as a BI user and start to dig in through Tableau to our Snowflake data. So I've created some content here inside of Snowflake to try and analyze this data. Let's refresh this. We can see that we've got, this is the amount of outstanding debt in each of our categories. Now, if I was trying to get a big boon to our AR, I would focus less on buildings and perhaps more on household and furniture and machinery. That'll give me a better view into receiving more data quickly. Let's come back into our workbook and we can take a look at other views of the data. Now we saw total debt per market segment pulling from Snowflake. We can also take a look at orders per market segment. We don't have a whole lot of consistency in our orders, so there's a few spikes here and a few low points, but we're not getting consistency across our orders. Let's look at quantity sold. Our sellers aren't selling consistently as well. We can look at this pretty much as an eye chart where no one seller is really making all that difference. You know, there's one seller right here that had sold 63 items. We can also take a step back and look at orders per country. Not a whole lot of correlation there as well, or quantity sold per country. I highlighted the circle size as the dollars per order. And basically the only thing we can learn from this graph is that when they buy more things, they spend more. Okay, so let's step out again, not per country, but per region. We have a few outliers, but for the most part, we don't have a whole lot of consistency with our data yet. If we're looking at accounts receivable per region, we can see we have a similar kind of graph where not a whole lot of consistency across our data. Looking at the products sold, a few high points, but not a lot. Popular products per quarter, we can see that there's a whole bunch of quarters where we didn't sell any of this particular product. Flipping over and taking a look at the products and sizes. Now, did our promo category really help us? Well, in nickel, maybe not so much. Our promo category is small, copper especially small. Our economy size is kind of working here, maybe not working so much here. So we might need to do a little bit more advertising on nickel. And our medium quantity looks to be the most popular in most places. So we might want to amp up there. That's pretty cool. We got to see lots of analytics with our Snowflake data on this fintech type of data content. And what's really cool is all of this access went straight into our SIM. Let's take a look at Elastic. Now, in this case, we've loaded the Cyral dashboard into Elastic, so we can take a look at the data monitoring activity and see the queries that we just made. Now, we've got some unique end user records because we've got some connections where they're just kind of validating that they can connect. But we can take a look at the groups that did queries. We can take a look at what type of queries they did, aggregate queries, column statistics. We can take a look at quantities of queries by group. It looks like the DevOps group was doing a lot of queries when I was pushing refresh in Mongo a lot. And then we can finally get down to the users attempting each activity. So do we have users that are really spiking here in our activity dashboard? That may be a sense that this account is compromised or shared in ways that don't make sense. And we can always dig down into the actual data. I've filtered here by myself, taking a look at this data. Let's refresh it to get the queries we just did. And now we can take a look at each of those queries. So here's all the queries that we did recently. And we can see the various data stores that we looked at. And I also highlighted policy violations. Let's dig into a Mongo query. Now here in this Mongo query, we can see the details of the query. Here's what I'm trying to find. And we can also see the identity information. Here's the identity. So here's me. I went to go log into this Mongo database. And we then used this account to get that last mile into Mongo Atlas. We have these details about the client. We have these details about the query. We have all of the logs that we need here in our SIM, where we can make really elegant business decisions. In a similar way that we can connect to Mongo, let's take a look at Snowflake, and we can see similar details right in line where I have the details of the activity that I was trying to do, and I have the details of the user identity here. Rob Rich was connecting to this database, and we used Nancy Drew to get the last mile into our data store. We also have details about when I violated that policy. So let's take a look at one of those. Here in Mongo, I wasn't allowed to get this many records. So we can see that we have this policy violated right here, where we can take additional action. And it's going to show us more detail about the policies that were violated. The sensitive policy, I asked for 20 records, but I should only have been able to receive 10. So this query was blocked straight away. These are great details that we have in our SIM so that we can start to make really intelligent decisions with our business data. Now, it was great to be able to take a look at this and see how we can leverage our Okta identity information to get access to our data stores. With these Cyral sidecars in place, we can log all that data off to our SIM and make really great business decisions, whether we're authenticating to Mongo or authenticating to Snowflake from a custom API, or in this case, a database administration tool, or from established business analytics tools like Tableau. Cyral is the first cloud-native security service that delivers consistent visibility, security, and governance for databases and data lakes. I love that we got to see how we could dig into both Snowflake and Mongo, a relational and a non-relational store, and show how Cyral was able to focus in on that user identity and help us make data access governance decisions. This has been a lot of fun getting to show you Cyral and how it can empower data access governance within your organization. If you're watching this video later, hit me up on Twitter at Rob_Rich or email us at info@cyral.com. For those of you who are here live in the event, what are your thoughts? What are your questions?
Hey Rob, so I'm looking through some of these questions right now, so I'll start reading them off as we get them in.
That sounds great. And what's really cool, you can grab the slides right now on robrich.org.
Perfect. Yes, of course. And so the first question is, what is the first step in getting rid of my service accounts?
Ooh, good question. Service accounts are really easy to abuse and use accidentally. So you notice how we moved away from our service accounts connecting from our API to our data store, and instead leverage the JOT token coming from the web application to be able to set that in place. If you can get to that level, that's a great way of starting to eliminate service account abuse. Part of it may just be rotating the keys because, well, at the point where you rotate the keys, you'll get messages from all those users who are suddenly locked out. Yeah, now let's look at a different way to authenticate you into that data store rather than grabbing the credentials from the service account baked into the application.
Awesome. This next question reads, I'm using service accounts in APIs so I can pool database connections. Should I abandon it in favor of user-specific connections? And then this question also notes that seems like a step backwards in performance.
I agree. And let's go back to this data access diagram where we saw exactly that. We have these service accounts that we're using so that we can pull the database connections into our sidecar. Now, if I have a unique connection per API request, I can no longer pool my connections. Now, what's really elegant is that you can have a pool of connections that authenticate with a different account, maybe a service account, and still give that attribution information, that identity information, via a SQL comment to be able to authenticate into your data store. So you can still use pooled connections, but you still get that identity in your SIM logs, coming in from the user's identity from the JOT passed into the API. So you don't need to necessarily abandon your connection pooling, but you can still get that identity attribution with Cyral. Great question.
So this question reads, if I am already authorized into Snowflake, what benefit is Cyral adding?
Good question. You're holding a key that gets you into the database, but from a data access governance perspective, how do we know that that's the correct key? We talked about how it's really easy to use shared accounts into Snowflake to avoid the license costs, or maybe we're using shared accounts into Tableau. Now, maybe they're already OAuth accounts, but by adding Cyral to proxy this data, we get the logs not only in the Snowflake spot, but also in our SIM, where we can create actionable and relevant alerts and detail associated with our business use of that data. The primary thing you get when you add Cyral in front of Snowflake is that visibility in your SIM.
This next question reads, why can't I just use the application logs to document users' data activities?
Good question. When we're looking at this data access model, we could probably assume that the user who authenticated to the web app hit the REST API. So let's just use the REST API's logs to be able to track who accessed our Mongo database. Well, we could, but that's not the only access into our data store. We used Mongo Compass in this diagram in this demo to be able to authenticate to Mongo directly. And that connection wouldn't end up in our API logs at all. So what's the benefit to adding Cyral here? I get a whole lot more user identity information. The app's access logs are okay, but application access logs are not data store access logs. There are lots of uses of our data store that don't flow through our application.
And how is this architecture different if my transactional database is relational and my analytical data store is a document database?
Good question. In this case, Mongo is our document store and we're using it for transactional details, and Snowflake is a relational store and we're using it for analytics. What if we flip those? What if we had Oracle or SQL Server here and we were using Mongo or Redis here? Ultimately, we saw how this Cyral sidecar in this VLAN allows us to proxy connections to whatever data stores we need. So how would this architecture be different if we use different data stores? It wouldn't be. It would be identical. We would just proxy through the sidecar into a different data store as well. Whatever connection tools we were using to connect it would connect as if they were connecting to the raw data store. But it just happens to authenticate to the Cyral sidecar instead, allowing us to validate that information through our identity provider and log that information into our SIM. Great question, thanks.
So it looks like at this point, I have one final question for you. So we'll see if we get any more before you're done answering this one. But this question reads, how can I impress on my teams the importance of not sharing the role-based database credentials with other teams?
Yes, shared accounts are by definition shared, and that is a really difficult wicket to solve. How do I tell them that these are really secrets, that they shouldn't share beyond the team? And that person who recently left the team who says, hey, can I just help with that one thing? It's difficult to impress on your employees the importance of not sharing shared credentials when they're specifically called shared credentials. If that's really your concern, then maybe shared credentials are not a great solution, and you should move towards user-specific accounts so that you can really impress on them that these are not to be shared.
Awesome. Thank you so much, Rob. I'm going to go ahead and announce our gift card winners, and just to give the audience a couple more seconds to submit any questions they might have. So, and also a quick reminder that today's session was recorded. So following this webinar, you'll receive an email with a link to access the on-demand recording. You can also find the recording living on the Security Boulevard website. Just visit securityboulevard.com/webinars. Quickly,
And grab the slides right now on robrich.org.
Yes, and in that sticky message right there at the top of the chat.
Perfect.
So quickly, our
so who won the gift cards? Did I win?
Our 4 winners today are Seth K, Peter S, Sophia C, and Walter P. So sorry, Rob, you did not win this time.
Not to worry. Thank you for joining us, everybody. And I'm so glad that you got to experience some of the benefits of Cyral and eliminating shared accounts.
Awesome. To our winners, keep an eye on your inbox to claim those cards. And if you don't see an email, just check your spam folder. So Rob, thank you so much for being here with us today, for sharing this demo, and for the chance to get to talk with you before we went live today.
Most definitely. This has been so much fun. Thanks for joining us, everyone.
I'd like to thank Cyral for sponsoring today's webinar. And my final thanks goes to you, our audience, for being with us for the entirety of today's program. This concludes today's presentation. Please take a moment to fill out our post-webinar survey, and we hope to see you at a future TechStrong webinar.